Hello, ladies and gentlemen. Notes 4.2 are on solving equations using substitution. We already discussed page 4 in class, so if you could now turn to page 5, and this is a list of steps to solve a system of equations using substitution. If you forgot how to do it, all you have to do is go back to this page right here, and all your information will be here for you. So, the equation that we're going to solve is 3x minus 2y equals 11 and x plus 2y equals 9. So let's look at the steps that we have in order to solve this problem. Step 1 is to isolate a variable in one equation. Look for the easiest variable to isolate. So we actually have 4 choices of variables. We can either isolate this x, we can isolate this y, we can isolate this x right here, or we can isolate this y right here. It's 100% up to you, but don't make your life difficult. So do you see this x right here, the first one that we have right here? In order to isolate that x, we're going to eventually have to divide by 3. And 2 and 11 are not divisible by 3, so you're going to have to deal with fractions. If you can avoid it, okay? Same thing with this 2y. Eventually, you're going to have to divide by either 2 or negative 2, depending on what side you get the 2y on. Regardless, 3 and 11 are not divisible by 2, so again, you're going to have to deal with fractions. Sometimes you'll have to deal with fractions, but if you can avoid it, avoid it. See this x right here? It has a coefficient of 1. Everything is divisible by 1, so that's going to be the easiest variable to isolate. So what I'm going to do is I'm going to color code my equations so you can see what I'm talking about. I'm going to color code the top one blue, and the bottom one I'm going to color code it red. So x plus 2y equals 9. In order to isolate the y, I'm just going to subtract 2y from both sides. So I get x equals 9 minus 2y. Okay, now the reason why this method is called substitution is because you are going to substitute that into the other equation. So make sure that when you take this and you plug it into the other equation, not the one you isolated the x in, because if you plug it back into the one that you isolated x in, you'll end up getting 0 equals 0, which really isn't very helpful to you. Okay, so let's go ahead and plug it in. So 3x minus 2y equals 11. So then every time I see an x, I'm going to replace it with all of this stuff right here, because this is what x is actually equal to. So I'm not changing it, I'm just writing it with something different. So x is equal to 9 minus 2y, so I'm going to replace the x with 9 minus 2y. And then I'm going to copy the rest of the equation down. So minus 2y equals 11. Okay, now if you notice, this equation had 2 variables. This equation only has 1 variable. Now it's so easy to solve. You know how to solve equations with just 1 variable in it. So let's go ahead and solve this equation. So step 3, now that you only have 1 variable in the equation, solve it. So I'm going to distribute the 3 through. So I end up getting 27 minus 6y minus 2y equals 11. Okay, so then I get 27. Combine your like terms, you get negative 8y equals 11. Subtract the 27 from both sides, you get negative 8y equals negative 16, which means that y equals 2 when you divide both sides by negative 8. Okay, now that I know what y is, and I actually have an actual number for y, I can take that number, this 2, and plug it into either equation that I want. The top equation, the blue one that we have up here, or the red one, the bottom equation. Totally up to you. I'm going to plug it into the bottom one only because it looks simpler, and I don't want to have to worry about making any mistakes. So every time I see a y, I'm going to replace it with a 2. And that's equal to, sorry, this is my red equation, that's equal to 9, right? So I get x plus 2y equals 9. Go ahead and solve it. X plus 4 equals 9. X equals 5. So then that means that my answer is 5, 2. So it says to write your answer as a coordinate. So my answer right here that I get is 5, 2. Which is where my 2 graphs would intersect if I were to graph them out, just like we learned in our last video. Last thing I need to do is check the solution in both equations. So I'll go ahead and do that. I'm going to split this down the middle so that I can check the equation twice, especially since there's two equations, right? So the first equation was 3x minus 2y equals 11. So I'm going to go ahead and write that down. 3x minus 2y equals 11. But instead of x, I'm going to replace it with 5. And instead of y, I'm going to replace it with 2. Okay? So I'm going to replace this guy right here with a 2. Then I'm just going to go ahead and evaluate. So I get 15 minus 4 equals 11, and then 11 equals 11. So I know that I'm good with one equation, so I'm only 50% sure that my answer is right. Now I got to check it in my other equation. So x plus 2y equals 9. Okay, so every time I see an x, I'm going to replace it with 5. Every time I see a y, I'm going to replace it with a 2. So right here, this is going to be a 2, and this is going to be a 5. So then when I add it all together, I get 5 plus 4 equals 9. 9 equals 9, and now I am good to go. All right, now if you turn to page 6, we discussed a little bit of this in class already, solving systems of equations using elimination. So what I want you to do now is we are going to actually do some of these problems. So turn to page 7, and we'll do question number 1 together. Okay, so now your goal in question number 1 is to either eliminate the x's or eliminate the y's. It is totally your choice. Since the x's have the same coefficient, I'm going to eliminate those. But don't forget that the only way you can get them to eliminate is if the signs are opposites of each other. They have to be inverses of each other. So what I'm going to do is I'm going to multiply the top equation by -1. So this turns into negative x minus y equals negative 18. Then I'm going to just copy the bottom equation down because there's nothing I really need to change on it, okay? Now, when I add my equations together, this negative x and this positive x give you 0, so they completely cancel each other out, okay? And then you end up getting negative y plus 2y equals y, and negative 18 plus 25 equals 7. So now all I have to do is plug it into any equation you want and solve for x. So I'm going to plug it into the top one. So I'm going to say x plus 7 equals 18, all right? And then now that I know this part right here, it's again one variable. So I can just subtract the 7 from both sides. I get x equals 11. So my coordinate would be 11, 7. All right, please take a look at question number 2. 3x minus 5y equals 3 and 4x plus 5y equals 4. Again, I can choose to eliminate either the x's or the y's. But if you look at the y's, they already have the same coefficients, and the coefficients are opposites of each other. So I don't have to do anything at all. I can, in order to change my numbers, all I have to do is go straight to adding my equations together. Remember, we're going to eliminate the y's because the negative 5y and the positive 5y cancel each other out. 3x plus 4x gives you 7x. Negative 5y plus 5y goes away, so you get 3 plus 4 on this side, which is 7. Divide both sides by 7, and x equals 1. Now that you know what x is, you can take it and plug it into any equation you want and solve for y. So I'm going to plug it into 4x plus 5y equals 4. Again, it's your choice. If you want to plug it into the top one, that's totally fine. So you get 4 times 1 plus 5y equals 4, okay? So then I'm going to just go ahead and continue solving. Subtract the 4 from both sides, I get 5y equals 0. A lot of people think at this point that there's no solution. There is a solution, it's just that the solution is that y equals 0. You only get no solution if you get two completely unequal numbers, but since y is a variable, it's still possible for me to solve. Okay, so that means that my answer would be 1, 0. Now, before we move on, I want to make sure you understand anything, or understand something. Right here, when you added the negative 5y and the positive 5y together and they eliminated each other, this was the only elimination you do. Once you solve for a variable, the rest of the process is just substitution. You don't have to go back up here and now eliminate the x's so you can solve for y's. It's fine if you do, but it's just a lot of extra work that's unnecessary. All right, let's take a look at number 3. It says x plus y equals 14 and 9x minus 9y equals 36. So my coefficients do not match up. This is 1, this is 1, this is 9, this is negative 9. So I'm going to get either the x's to line up or the y's to line up and to have the exact same coefficients except opposite signs. So again, it's your choice. I'm going to choose the y only because this y and this y are opposite signs already. So that gives me one less thing to worry about. So what I'm going to do is I'm going to multiply the top equation by 9 because the least common multiple of 1 and 9 is 9, okay? So when I multiply it by 9, I end up getting 9x plus 9y equals 126. Okay, and then here I'm just going to copy the rest of this equation down, which is 9x minus 9y equals 36. Okay, so now all I have to do is combine my like terms. 9x plus 9x is 18x. Right? And then this 9y and this negative 9y will cancel each other out, and I just have to add 126 to 36, which would give me 162. Okay, so now all I have to do is divide both sides by 18, and I end up getting y equals 9. Okay, now that I know what y is, I can plug it into any equation I want and solve for x. So I'm going to plug it into the top equation. X plus y equals 14. And instead of y, I'm going to replace it with this 9. So x plus 9 equals 14. Solve for x, you end up getting x equals 5. Which means that your answer would be 5, 9. Okay? Obviously, you would go through and do your checking. But we're not going to do that right now for the sake of time, especially since we've already talked about checking multiple times. Number 4 is a little tricky, mainly because the x's and the y's are together on one side on the bottom equation, but they're on opposite sides on the top equation. And in order to be able to do this, they have to line up. So they don't line up because this x is on the left side and this x is on the right side. But all I have to do is move one set of x's to the opposite side for either equation. Totally up to you again which one you want to do. So what I'm going to do is I'm going to add 2x to both sides of the top equation and then rewrite the top equation so that way it looks similar to the bottom equation, okay? And then once I do that, I can choose, do I want to eliminate my x's or do I want to eliminate my y's? Again, it's your choice. If you eliminate the x's, you have to find the least common multiple of 2 and 5. If you eliminate the y's, you have to find the least common multiple of 3 and 4. I'll just go ahead and eliminate the x's. I'm just arbitrarily choosing x. It doesn't matter which one you choose. So the least common multiple of 2 and 5 is 10. So I'm going to change my x's into 10x. And the way I would do that is multiply the top equation by 5. And then I would have to multiply the bottom equation by 2. But before I do any of that stuff, 10x and 10x, when I add them together, will not cancel each other out. I need one of these x's to be a negative 10x. So I'm going to multiply the bottom equation by a negative 2. Again, you can choose to do it to the top or the bottom. So the top equation turns into 10x plus 15y equals 25. Okay? And the bottom equation turns into negative 10x minus 8y equals negative 32. Now I can add my equations together, and 10x minus 10x eliminates, so we've done it correctly because the x's go away. 15y minus 8y is 7y, and then 25 minus 32 is negative 7, which means that y equals negative 1. Now you can go ahead and plug that into either equation that you want in order to solve for x. I'm going to plug it into the bottom one just because that's what I randomly decided to do. 5x plus 4y equals 16, but instead of a 4y, I'm going to say 4 times negative 1. And then I'm going to go ahead and solve, okay? So I get 5x minus 4 equals 16, which means that 5x equals 20, which means that x equals 4. Okay, so then my final solution will be 4, -1, and I am done. So you've learned 3 different ways to solve a system of equations. You can use substitution, elimination, or graphing. Unless it specifically says which method to use, at this point in time, you can use any method you want. All right, have a good day.